So we are currently in our test directory. Let's create an empty text file with the touch command like we did in our previous video. Now, if we want to add a few lines of text to that file, we can use any text editor. Let's do that with a GUI based text editor. Open the file, add a line of text, save and close it. Then let's add a few more lines with terminal based text editors like Nano and Vim. Open it by typing nano new file.txt, add a line of text, press Ctrl O and enter to save and Ctrl X to exit. Then open the same file with Vim new file.txt. Press I for insert mode, add a line of text, press escape and type :WQ to write and quit. As you can see, text files can be viewed and edited with text editors. We can also create new files using these text editors. gedit new gedit file.txt, which is similar to opening a gedit application and saving it with a name, or vim new vim file.txt. You can name the files anything. Just to distinguish them, I use these names. Now, to view the content of a text file within the terminal, we can use a command called cat, short for concatenation. Cat new file.txt. Remember that we are dealing with small files, and cat is perfect to view small files. As the name suggests, the actual usage of cat command is to merge content. So it takes the content from multiple input files and gives a combined output. Since we now know how to use a wildcard, we can just type cat new _* to view the merged output. By default, cat sends its standard output to the terminal. Not only the cat command, even the pwd and ls commands just print their standard output to the terminal. What we can do is, we can redirect the standard output to a file instead of printing it to the terminal. To do that, we can use the right facing angle bracket or chevron. So we can type cat new _* right angle bracket merge file.txt. When we do this, we don't see any output in the terminal. If we view the merged files again by using cat, we can see the concatenated output. The standard output of any command can be redirected to a specific file. Let's have a look at another command called echo. This command prints out whatever is following it. Echo something. So as we did earlier, we can redirect echo's standard output to a file. Echo something right angle bracket test file.txt and then view it with cat. What happens if we redirect something else to the same file? Well, it overwrites the file with the new content. If we want to add or append to the existing content, we have to use double angle brackets. If you have noticed, we have been creating new files while redirecting. So if right angle bracket redirects standard output, what would left angle bracket do? As you might have guessed, it redirects standard input. Let's look at the cat command one more time. We may think that it needs at least one argument as input, which is the file. However, if we check the help output, we can see that the file is enclosed in square brackets, which means it is optional. So if we type cat, it waits for us to give input. Whatever we type now is the standard input. And when we press the enter key, it gives the same as standard output. Let's stop it by hitting Ctrl C. So now, instead of making the cat command wait for the standard input, we can actually redirect a file as standard input to cat. Cat left angle bracket new file.txt. The output is exactly same as earlier, but the way we are providing the input to cat is different. Earlier we were using a positional argument. whereas this is a file redirection. Now let's make the cat command throw an error. If we provide a wrong file name or a file that doesn't exist, it is going to throw an error. This is again shown in the terminal. Can we save this error to a file? Say error.log. Let's try. Cat got file, right angle bracket, error.log. Well, it is still printing to the terminal and we don't have anything saved in the error log. This is because what is getting printed to the terminal is not standard output, but a standard error. To redirect standard error, we need to use a different redirection symbol, which is 2 right angle bracket. So typing 2 right angle bracket error.log redirects the standard error to a file. We don't see the error in the terminal now. So if we have 2 right angle bracket representation, there should be 1 right angle bracket representation as well, right? Yes, it exists. Actually, 1 right angle bracket is the standard output redirection. What we have used earlier, just the right angle bracket, is a shortcut. So 1 right angle bracket and just the right angle bracket do the same thing, redirect standard output. Let's try it with ls to redirect its output to a new file and then view the file. Right. Before introducing the next type of redirection, let us look at a command called wc. This command counts the number of lines, words and characters in a file. Let's try it on the testfile.txt. The output says that the file has 2 lines, 7 words and 41 characters. We can also specify flags to get specific output like -l to get just the line count, -w for word count and -m for character count. Let's try with a new file, which is an output of redirecting ls home. Now instead of redirecting the standard output of ls home to a file, we can directly give it as a standard input for wc. We can do this using the pipe character like this: ls home pipe wc. As we can see, both outputs are the same. We can chain multiple commands using the pipe character. We will see that in a minute. So while we were redirecting the standard output of our commands, there was no output to the terminal. But what if we could both print and redirect the standard output? This can be done by piping the standard output to a command called t. So instead of the actual redirection, we can use pipe t and the file name. If we try to add extra information to the same file, it actually overwrites it. To append content to the same file, we can use the -a flag with t. Can we do the same for standard error? We can, but the t command needs standard output as standard input, not the standard error. So first we have to do another redirection of the standard error as standard output and then pipe it to the t command. Here's how it looks. ls got throws standard error, ls got 2 right angle bracket error.log redirects standard error to a file. Instead of redirecting to a file, we can make it a standard output by adding &1. Now we are dealing with standard output instead of standard error. Finally, pipe it to t. Now we have printed to the terminal as well as redirected to a file. What if we don't want to redirect or print to the terminal? We can do that as well by redirecting the output to dev null device. Why is this happening? The root del directory is where all our devices like SSD, graphics card and network devices are represented as files so that we can interact with the devices like those are regular files. Root dev/null is a null device. it acts as a sink. Whatever is written to that file just vanishes. That's why redirecting the standard output or standard error to dev null does not print to the terminal. Okay, that's too much redirection. Let's look at a few more useful commands. If we run ls-lah home, we get a long list of the contents from our home directory. Let's redirect that to a file. Now, to see which of these files were modified in March or any other month as per the dates in your output, we can use the grep command, which searches for patterns. So we can see that our output has the date column with month names. We can use grep to find all those lines that have MAR in them. This gives out only those lines that have MAR. And we can see that the matched pattern is highlighted. But how many lines have MAR in them? We can add the C flag to the previous command and get the count instead of the actual list. Let's try a few more pattern searches. Search for some other month that is present in your list, like APR in my case. Okay, all these lines have APR. Search for the one that doesn't exist. We won't get any output, which means there is nothing like that in our file. How about adding the day along with the month? MAR space 21. Well, this is not what we were expecting. What it is doing is it is searching for MAR in files named 21 and files in home.txt. What we actually have to do is provide the pattern enclosed in quotations. Now it shows the pattern. Remember that we are searching for patterns, not the actual characters. That means we have special syntax for searching patterns, which are also known as regular expressions. In fact, grep stands for Global Regular Expression Print. Check regex1.com to learn more about regular expressions. Some of the characters like dot, question mark, plus, etc. have special meanings. Let's see an example. If we want to see which lines have dots in them, providing just the dot character as such to grep will output all characters highlighted. That means it is matching each and every character in the file. If we check the meaning of dot in regex syntax, we will see that it represents any character. So to search for the actual dot character in our file, we have to prefix a backslash, which is an escape character in regex syntax. Now it highlights all the instances of the dot character in our file. Similarly, backslash lowercase s represents any whitespace character. So searching for MAR space 21 is same as searching for MAR backslash s21. To keep it simple, we will try to avoid regex syntax in this video. We can also do an inverse search. Say we want to see which lines have bash in them. We can type grep bash and the file name. Whereas to search the lines which do not have bash in them, we can add the v flag to our previous command. So here v flag doesn't mean verbose like the cp and rm commands. We can also get the line numbers by adding the n flag. Let's pipe grep with other commands. Now let's see how many items in our home directory were created in March or whichever month you have in your output. Okay, all these files we have been dealing with are tiny files. All are within 2 KB. Let's get a larger file. If you search for example CSV files, we can see a GitHub repo with such files. Let's download the 10,000 customers CSV file. And then move it to our test directory. A CSV file is just a text file with comma separated values. We can open it with Microsoft Excel like applications or a text editor. Since we cannot install Microsoft Office as such, we can use LibreOffice in Linux to deal with Word documents and datasheets. So what we have downloaded is a datasheet of 10,000 individuals with their contact details. We have seen that cat can be used to view such text files. However, since we are dealing with 10,000 entries, if we use cat, our terminal gets filled with the file's content, and it may not be useful from the user's perspective. So instead of viewing all the file's content at a time, we can use the less command to view it in a page format. We can use the up and down arrow keys to navigate through the content. To exit from page view, hit Q. Further, to get an overview of the content, we can use head file name to see the first 10 lines, or tail file name to see the last 10 lines. Both head and tail take additional flags like N, which allows us to specify the number of lines to view. Before proceeding to the next command, let's create a simple CSV file with 6 rows and 3 columns using the echo command. Let's save it as friendsjobs.csv. We know that the values are separated by commas. The comma here is a separator or a field delimiter. You will also encounter files having a tab as the separator. These are TSV formatted files. So let's convert our CSV file to a TSV file. For that, let's make a copy of our CSV file and give a different name and file extension. Since we have copied as such, we still have commas in our TSV file as well. To replace the commas with tabs in our TSV file, we can use a command called sed. The sed command takes an expression and a file as input and executes that expression on the file's content. So here the file name is our friends altjobs.tsv and the expression is the pattern replacement. The expression goes between quotation marks and it follows the following format: substitute, search pattern, replacement string. Let's start with something simple. Rachel was working as a waitress before landing in her dream job. So to replace her occupation, we can type sed in quotations yes for substitute, fashion exec, waitress, and then the file name. Whereas Phoebe had many other jobs and one of those was a singer. If you have observed, sed is not replacing the original content. The standard output for sed is to print to the terminal. So to make the actual replacement, we have to add the I flag, which stands for in place replacement. So if we add the I flag to both of our previous commands, we have now modified the actual file. Note that we are searching for patterns that have occurred only once in the file. Now let's try replacing the separator, which is occurring multiple times in the file. Let me remove the I flag so that we can preview what the output would be. So if we use a similar expression to replace the commas with hyphens, what we get is not the expected output. It is changing only the first instance of the comma in each line with a hyphen. This is because the expression in its current format changes only the first occurrence of the provided search pattern. We can change this by adding G at the end of the expression, which implies performing the global substitution. So to replace the commas with tabs, we can type sed s comma \t g and then the file name. The output is as expected. Now let's perform the in-place replacement by adding the I flag. Just like other commands, sed can take input from a piped command. Let's convert the main jobs CSV file to a TSV file by piping the commands. Right. In our new friendsjobs.tsv file, we have 3 columns: serial number, name, and occupation. What if we want just the name column? We can actually extract a specific column or columns using a command called cut. The cut command uses a f flag to extract the columns or fields. So to extract the name column, which is the second one, we can type cut -f2 and the file name. If we want both the name and occupation, we can type cut -f2 to 3 file name or 2, 3. Or say if we want to extract the first and third columns, we can type cut -f1, 3 file name. However, if we try this on our CSV file, we don't get the expected output. This is because the cut command expects a tab as the default separator. We can change that by providing a custom separator to the cut command using the d flag. Let's go back to our customer CSV file. If we open it with gedit, we can see that there are comma characters within some values. These are not separators. These are actual comma characters. We have a pattern here. All these literal comma characters have a space immediately after. This is not the case with the actual separators. So first we will replace these with some other character so that the cut command's delimiter option would not consider these as separators. Make sure you are not replacing the separators. So first we will try with a few of the values. And then do the actual replacement. Right. The first line in our CSV file contains the column names. By using the commands we have looked so far, let's see how many countries our customers are from. While finding this out, we will look at 2 new commands, sort and uniq, which are pretty straightforward to understand. The first thing we need to know is the column number to extract. Head-n1 and the file name gives us just the first line, which has the column names. Let's replace commas with new lines. How many columns do we have? 12. And what is the position of the country column? 7. Now we can extract the country column with cut. We can see that the column name is also included in the output. Let's remove that. We can also see there are duplicates. We can get a better view of the duplicates using the sort command. At this stage, that is after sorting, we can use the uniq command to get the unique list of countries and then count the number of countries. So we have customers from 243 countries. Note that uniq cannot identify the duplicates if they are lines apart. So if we try to find unique items before sorting, we get a different number. So use sort before running uniq. Earlier, we used the cat command to merge files. Now, if we want to do the opposite, split a large file into smaller chunks, we can use the split command. It's not a direct reverse of cat command, but it lets you break a file into parts based on a specified number of lines per file. Before using split, let's remove the column names from our CSV file so that we can have just the 10,000 rows. Then let's split the new file. The default behavior of this command is to split the input file into shorter files with 1000 lines. Save the output in the current directory. Add X as a prefix to the file name. And add 2 letters as suffix. We can change all this. Let's remove the outputs first. Add a custom prefix. Now let's save the output to a new directory. Use numbers instead of letters as the suffix with D flag. Now we can see that each file has 1000 lines. To change that, we can add the L flag to the split command. That's about the standard streams and text manipulation. In the next video, we will see how to change permissions and how to retrieve system information.